Hello. In today's lesson, we're going to talk about finding permutations and finding combinations and just kind of what both of those things are. So to start off with, we're going to have to understand what a factorial is. Now, a factorial of a positive integer is the product of all of the positive integers up to and including that integer. Just one note, if you ever have 0 factorial, that will be defined as 1. So what that means, just if I was going to give you a quick example, if we had 3 factorial, that just means that's going to be 3 times 2 times 1. So if you had 100 factorial, that would be 100 times 99 all the way down to 1. So 3 factorial would give us 6. All right, so moving on, our first example, we have 5 factorial. So that's going to be equal to 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20, times 3 is 60, times 2 is 120, and times 1 will give us 120. Now, for the second one, we have 10 factorial divided by 2 factorial times 10 minus 2. So that 10 minus 2 will give us 8 factorial. So I'm going to simplify this problem just to make it a little bit easier for us, because 10 factorial is 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. Now, those two bottom pieces, 2 times 1, we have here. In the second part, we have 8 times 7, 6, 5, 4, 3, 2, 1. Now, rather than multiplying everything out, I'm just going to cancel those pieces out. Now, if I had realized this before, what I could have done was said 10 times 9 times 8 factorial, because I know that I'm multiplying by everything below. And then we have 8 factorial right here, which would cancel out. So really, it's just going to be 10 times 9, which is 90, divided by 2 times 1, which is 2, which will give us 45 in the very end. Okay? Hopefully that made sense to you. Just the two ways that I kind of did it there. All right, so our first piece, a permutation, a selection of items where order is important. Now, the fact that order is important is very important for this definition. The permutation of n objects taken r at a time, we have this notation p dealing with permutation, n comma r. So we have n factorial divided by n minus r factorial in parentheses. Second one, combination. In a combination, order is not important, or order does not matter. I have the wrong word there. That should be combination of n objects taken r at a time. The only difference here is you'll notice we have that r factorial before our parenthesis piece. Okay, so those are our two big kind of equations that we'll be using to find combinations and permutations. So find the permutation of 8 objects. So because they don't tell us that they're taken r at a time or anything like that, that's just going to be 8 factorial. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, I'm going to multiply these in a way that I can best, or make it as easy on myself as I possibly can. So this is going to give me a 20, and I'll do 20 times 8 since that's my biggest number. So 20 times 8 will give me 160. Let's do 160 times 6. And then I still have a 6 and a 7, so let's do 960 times, we'll do times 42, just kind of chunking things up. 0, 12, 18, 19, 0, 0, 24, 36, 38. So we'll get 0, 2, 13. So 8 factorial is going to give us 40,320. Okay, so quite a bit of work of just multiplying. There is a way you can do this on your calculator, and I'll show you guys in class how to find that factorial button. Permutations, 6 objects taken 2 at a time. So that means n is our 6, and we're taking 2 at a time. So it's going to be 6 factorial over 6 minus 2 factorial. So that's going to be a 4. So again, I can just do really 6 times 5 times 4 factorial, which is going to be the same as the bottom. So those two cancel out. 6 times 5 is 30. And then this last one is a little bit tricky. So find the number of distinguishable permutations of letters in the words connection. So n is how many letters we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, this one is a little bit different and doesn't follow our definition perfectly. Now, I'm going to break it up. Rather than calling these R, I'm going to call them Q1. And a Q1 is going to be if I have a letter that's repeated. So I have a C 2 times. So that'll be a 2. I also have an O 2 times. And I have I have 3 N's. So in this one, all I'm going to have to do is I'll do 10 factorial divided by 2 factorial times 2 factorial times 3 factorial. And I know that one doesn't really follow the general flow of the rest of them, but this is a way that you can find the permutation of a letter with repeating letters. So 10 factorial, not just 10, that actually gives us 3,628,800. And then that would be divided by 2 times 2 times 6, because 3 factorial is 3 times 2 times 1. So that'll give us 4 times 6, so 3,628,800 divided by 24. Our answer for that is, whoops, I'm trying to move my screen, 151,200. Okay, so that's the number of distinguishable permutations for the word connection. All right, now finding combinations. So if we want to find the combination of 7 objects taken 4 at a time, like I said, it's a lot like that permutation equation. However, we just have that R factorial out first. So we have 7 factorial all over 4 factorial, and then 7 minus 4 factorial. So that'll give us 3. So we have 7 times 6 times 5 times 4 factorial, I'm going to say. And that 4 factorial will cancel out with that one. So I'm going to have 30 times 7. 7 times 3 is 21, so 30 times 7 would be 210. I'm going to move this down here. Divided by 3 times 2 times 1 would give us 6. And then let's do some long division here. That'd be 3, 18, 3, drop down that, and we get a 5. So 35 different combinations. So remember, combinations is where order is not important. Show you guys a little different one here. How many different pizza varieties can be created if there are 2 choices of crust, thick or thin, and 2 out of 3 possible toppings are selected? Okay, so as I have in parentheses here, this time we're going to have to separate our combinations. So we're going to have 2 different combinations, one for toppings, one for our crust. So our crust, we have 2, and we get to choose 1. Okay, and then we would multiply by toppings. There's 3 total. We get to choose 2. And that'll be 3 minus 2, which isn't going to do a whole lot for us. So a 2 factorial times 1, or over 1 times 1. So that first part is going to give us 2. Times 3, which is 6. 3 factorial is 6. Divided by 2 is 3. So if we were multiplying these two things, we're going to get 6 total. Okay, so if I broke that down a little bit more, if you didn't get that, that'd be 2 times 1 over 1 times 1 multiplied by 3 times 2 over 2 times 1. Those 2's cancel out. Everything else is a 1, so it's just going to be 2 times 3, which equals 6. Okay, so then for example 4, we're trying to distinguish between permutations and combinations. So letter A, explain how whether the following is a combination or a permutation, and find the solution. How many 2-letter arrangements can be formed by the letters cat? So we have to ask ourselves, out of cat, if we have 2-letter arrangements, I know that 2 is going to equal my R, and there's 3 letters in cat, so N is equal to 3, regardless of whether it would be a permutation or combination. So is CA the same as AC? So in this, if we're looking for 2-letter arrangements, those 2 would not be equal, so that means that order is important. If order is important, that means that we are dealing with a permutation. Okay, so that means I'm going to be dealing with 3 factorial all over 3 minus 2 factorial. 3 because, again, N is 3 because there's 3 letters, and I'm choosing 2 at a time. So that's going to be 3 times 2, which equals 6 over 1. So there's going to be 6 total permutations of 2-letter arrangements for that word cat. The next one, explain whether the following is a combination or a permutation and find the solution. How many 2-man crews can be selected from the set of 3 males? Okay, so let's Tom, Bart, and Homer. Okay, so we have to ask ourselves, if I took Tom and Bart, is that the same as taking Bart and Tom? So in this scenario, yeah, that's exactly the same. So this is going to be a combination. Again, we have the same N equals 3 and R equals 2 because we're taking 2 at a time, but we're using the combination. So combination, that's going to be 3 factorial all over 2 factorial, and then 3 minus 2 factorial. So that's going to be 3 times 2 is 6 times 2, and that's going to be times 1. So we have 3 different combinations. Looks like we could either take Tom and Bart, Tom and Homer, or Bart and Homer. I almost finished up here. Oh, we are finished up. Here is your lesson practice if you are gone. You can write this on a separate sheet of paper and then get that turned in. Give you a second to pause it and get those written down. And here's your homework, page 309, 1 to 10, 12 to 22, and 25 to 28. Hope you guys have a great day.